Okay, Algebra 1 fans, our topic for today, this is Note 7-1, Multiply Monomials, Day 2. So we're continuing the lesson that we started the previous day, Exponent Laws with Powers. Our objective after this lesson, students should be able to multiply monomials using exponent laws. Before we begin, let me give you your joke of the day. If you see a robbery at the Apple store, does that make you an eyewitness? Eyewitness, iPhone, iPad. Okay, so first part here, power to a power. That's an exponent raised to another exponent. Okay, so we're going to do a couple examples here. Number one is actually what we did last time. X raised to the fifth times x raised to the second. We keep the base, we add the exponents, and we get x raised to the seventh. Now in number two, we have x to the fifth in parentheses raised to another power, another exponent. Now one thing we can do is expand this. Anytime I square a number, for example 3, that means I multiply the base by itself 2 times. So this base is x to the fifth, and I'm going to multiply it by itself twice. Now, x to the fifth times x to the fifth, add the exponents, we get x to the 10th. Number 3, x to the fourth times x to the third, keep the base, add the exponents, 4 plus 3, x to the 7th. Now, if we raise the base to the third power, that means we take the base, the number in parentheses, and multiply it by itself 3 times. Now, I've written this as multiplication. When we multiply variables, keep the base, x, add the exponents, 12. Now, obviously, if this was to the 6th or the 10th or the 20th power, we don't want to write this out 20 times. So if you look at this, though, going back to number 2, x to the fifth raised to the second, and we ended up with an exponent of 10. Wait a minute, 5 times 2 is 10. Here, 4 times 3 is 12. So does that mean that we can multiply the powers together? And the answer is yes. When you have a power to a power, an exponent raised to another exponent, you are allowed to multiply those, that's the rule, and we get a raised to the m times n, or just mn power. If we have parentheses raised to a power, it's like distributing. This would be a raised to the m times p, b raised to the n times p. So this exponent, it doesn't multiply a and b, the power multiplies the other powers. It multiplies the other exponents. All right, so number 5, x cubed raised to the 7th. Well, that's x to the 21st. That's it. When you have an exponent raised to another exponent, we multiply them together. Okay, number 6, x to the 17th is raised to the 3rd. Y to the 4th is raised to the 3rd. So for both of these, we multiply the exponents. 17 times 3 is 51. Y to the 3 times 4 is 12. That's it. If we have a coefficient, that is 2 raised to the 1st. This exponent, the outside exponent, does multiply all the exponents inside. It is not 2 times 4, it's 2 raised to the 1 times 4, which is 4. X raised to the 1 times 4. Y raised to the 8 times 4, which is 32. Now I'm not going to leave it like that. I'm going to do one more thing. 2 raised to the 4th, that's 2 times 2 times 2 times 2. 4 times 2 is 8 times 2, 16, x to the 4th, y to the 32. That's as far as we go. Number 8, take the outside exponent, distribute to all the exponents inside. Now this is -3 to the second. I'm going to use parentheses because of this negative. X raised to the 4 times 2 is 8. Y raised to the 3 times 2 is 6. Now I talked about this last lesson. You need to be careful. When you square a negative, that means a negative times a negative. That is a positive 9. X to the 8th, y to the 6th. Number 9. Okay, we have a fraction coefficient. That's okay. I'm going to put the ones in for the exponents that are not listed. Okay, the outside exponent, we're raising all of this to the third power. So this becomes negative 1/4 to the third. X to the 3 times 3 is 9. Y to the 1 times 3 is 3. Z to the 5 times 3 is 15. Now, when we multiply this, negative 1/4 times itself 3 times. Negative 1 times negative 1 times negative 1 is negative 1. 4 times 4 times 4 is 64. So the fraction is negative 1/64, x to the 9th, y to the 3rd, z to the 15th. If you want to, you could write this as negative 1 x to the 9th, y to the 3rd, z to the 15th, all over 64. That's not wrong to do that. I'll just leave it like this. Number 10. 2 raised to the 5th, g raised to the 4 times 5, 20, h to the 11 times 5 is 55. Powers of 2, 2 raised to the 5th. Well, we know 2 to the 4th is 16, so 2 to the 5th is 16 times 2, 32. G to the 20th, h to the 55. The better you are with knowing your powers of 2 and 3, 4, 5 and stuff, using exponents, the faster you can do these problems. Okay, so let's flip on to the back. And okay, now it's going to start getting longer, but that's not harder. It just means there's more work to do. What I want to do is take care of parentheses first. Okay, so if I have outside exponents, if I have something parentheses raised to a power, I need to distribute that outside exponent. So that's x to the 28th times x to the 20th times, that's x to the 3rd. So we want to write this without parentheses, kind of like PEMDAS. Start with parentheses, simplify that, then look at what's left over. This is multiplication. When we multiply variables, we keep the base, add the exponents. I'll write it this time. When we add 28, 20, and 3, we get x raised to the 51. Number 12. You have a negative on the outside, but we're not going to distribute that yet because we do parentheses, then we do exponents. So I'm going to distribute this 3 here, this outside exponent. So this negative is going to stay like it is. Actually, I'm going to write that that's a negative 1. If there's no number there, that means that's a negative 1. Times, this is negative 2 to the 3rd, x to the 3rd. Now, when I do negative 2 times negative 2 times negative 2, that becomes negative 8, x to the 3rd. The last thing we can do is multiply the coefficients. A negative times a negative, we get positive 8, x to the 3rd. So there's an order to this. You have to use the order of operations. Parentheses, exponents, then do multiplication at the end. Number 13, parentheses, let's do exponents. I'm going to put the 1s in here. I'm going to distribute the outside exponent, the 2, x to the 2nd, y to the 2nd, z to the 8th, times, now we're going to distribute the 5, x to the 15th, y to the 5th, 1 times 5, z to the 2 times 5 is 10. Okay, now it's multiplication. When we multiply variables, keep the base, add the exponents. so that's x to the 17th. And then we have y. 2 and 5 adds up to 7. And then we have z. 8 and 10 adds up to 18. Z to the 18th. Number 14. Okay, let's see. We're going to distribute the outside exponent first. 5 squared, which will be 25. X to the 2 times 2 is 4. Y to the 2 times 3 is 6. Times negative 2 raised to the 3rd. X to the 12th. Y to the 21. Okay, I like to draw the arcs. You don't need to. I like to do that to remind myself I have to multiply these. 5 squared is 25. Negative 2 to the 3rd. Negative 2 times negative 2 times negative 2 is negative 8. Now these are the coefficients. We are going to multiply those together. 25 times negative 8. And we get negative 200. When we multiply variables, keep the base. Add the exponents. That's 16. And then for the y's, keep the base. Add the exponents. That's 27. And that's as far as we go. All right, the last type of problem here. If you have an exponent raised to an exponent raised to another exponent, then what we can do, I'm going to work from the outside in actually. The 4 would distribute to the 3 here. I'm going to multiply those. So that's x to the 2nd raised to the 12th. And then I can multiply that and we get x to the 24th. And that kind of looks like a negative 4, but that's just the bracket. I apologize for the confusion. For this one, okay, so we have negative 2. The outside exponents, the 2 and the 3, multiply that to 6. A negative number raised to an even power is going to be positive, and that would be positive 64. If you use the calculator, make sure that you're using parentheses. Negative 2 in parentheses, and then raised to the 6th. There's my 64. Okay, we got 2 more problems here. Okay. First thing, let's take care of the outside exponents. So negative 2 raised to the 4th, m to the 12th, n to the negative 4, p to the 16th, whew, that's a lot, times 5 to the 3rd, m to the 3rd, n to the 6, p to the 3. Negative 2 raised to the 4th is positive 16. 5 to the 3rd is 125. All right, I'm going to use the calculator here. 16 times 125 is 2,000. Okay, keep the base. Add the exponents. So m to the 15th. Keep the base. For the n, negative 4 plus 6 is 2. Keep the base, p. Add the exponent, 16 plus 3 is 19. That's it. That's as far as you go. Last one. Now, number 18. Before I start combining, before I multiply, I've got to take care of exponents. So I can do this 2 is outside these parentheses. X to the 8th, y to the 6th, z to the 12th. Now, here we have parentheses raised to a power, 2 times 4, that's really an 8. Now I can distribute the 8. So times 2 to the 8th, x to the 16, 8 times 2, y to the 16th. 2 raised to the 8th is 256. Multiply the x's, we keep the base. Add the exponents, that's 24. For the y's, keep the base. 6 plus 16 is 22. Z to the 12th is by itself, so that stays. And that is as far as you go with that, and that is the end of the notes.